Good morning, students. Let's do the second type of chi-square test. Here we will see the goodness of fit. Okay. So here the following table gives the number of accidents in a city during a week. Find whether the accidents are uniformly distributed over a week. So here it is given the number of accidents in a week. So Sunday, Monday, Tuesday, Wednesday, Thursday, Friday and Saturday, and total. And here number of accidents. On Sunday the number of accident is 13, Monday it is 15, Tuesday 9, Wednesday 11, Thursday 12, Friday 10, Saturday 14, and total 84. So here you are asked to check whether the accidents are uniformly distributed or not. Means we need to see whether the accidents happens at equal number on all the days. Okay, so here to solve this question I will take null hypothesis. Null hypothesis H naught, as you are asked to find whether the accidents are uniformly distributed over. So when goodness of fit is asked, you will take the positive statement, that is accidents are equally distributed. Equally distributed. In the previous one, when the attributes are independent, there you did, that is a negation we used to take. Okay, so here goodness of fit, you will take a positive statement, that is accidents are equally distributed, and here alternate hypothesis. Alternate hypothesis HA you will take, obviously accidents are equally distributed, then accidents are not equally distributed. So that is the alternate hypothesis. Now which statistics? Now we need to calculate the test statistic. So test statistic will be so statistic is chi-square equal to summation of O minus E the whole square divided by E. Okay, so here now to calculate this one, we have assumed that the accidents are equally distributed. So total there are 84 accidents. So if they are equally distributed, then in a day how many should come? So if the accidents are equally distributed, then number of accidents in a day, okay, then there will be total 84. It is given total 84 divided by 7, because 7 days in a week. That means 12 accidents per day if they are equally distributed. Okay, so this is what is given is the observed frequency. This is observed one, and we expect this one, that is if they are equally distributed, then we expect 12 accidents per day. Okay, so now I will calculate chi-square. So here O minus E the whole square, then O minus E the whole square divided by E. So O means first 13, 15, 9, 11, 12, 10, 14. Expected is 12, 12, 12, all 12s. and O minus E the whole square, you will get that, and then O minus E the whole square means 13 minus 12. The whole square means 1 square 1, 15 minus 12, 3, 3 square 9. So here also 9, 1, 0, 4, 4. Okay. Then O minus E the whole square by 9, 1 divided by 12. So 1 divided by 12, whatever it is, you will find all that. Then here you will get summation of O minus E the whole square divided by E. When you find the sum, this is equal to, you will get it as 2.33. Okay, 2.33. So you got the chi-square now. Now we need to find the level of significance. So 3, it is level of significance. If it is not given, take it as 5% or 1% or 10%. So as I told earlier, as an ideal case, it's better to take 5%. Okay, so I have taken it as 5% means 0.05. Then corresponding critical value. Critical value chi-square alpha is equal to how much at level of significance alpha equal to 5% and degree of freedom. Degrees of freedom nu equal to how many? N minus 1. That is total there are 7 data is there, 7 entries are there, N is 7. Okay, 1, 2, 3, 4, 5, 6, 7 days. Okay, so 7 minus 1 means 6. Degrees of freedom is 6. Then, so chi-square alpha at 6 degrees of freedom is 0.05 and 6 here, you will get the value 12.592. So this is 12.592. Okay, so that is the critical value. Now decision. Decision is chi-square calculated value. We got it as 2.33. This is very much less than chi-square table value alpha. Therefore, H0 is accepted. What was your H0? That is, accidents occur equally on all days. Therefore, we accept that hypothesis. That means the accidents are equally distributed over a week. So this is the first question. Okay, so this is goodness of fit. Now look at the second question. Please read the question very carefully. A die was thrown 132 times and the following frequencies were observed. Number obtained is given, frequency is given, and test the hypothesis that the die is unbiased. So a die was thrown 132 times. So here I will take H0. So question is test the hypothesis that the die is unbiased. So you know, when we throw a die, this data even you can find using binomial distribution or Poisson distribution. Okay, so mostly many of the cases we use binomial distribution to find this number and all. So if you find the frequencies using that binomial distribution, you may get like this. Okay, then here actually it is asked whether that goodness, that fit of binomial distribution is good or bad here. That is goodness of fit. Then here I will assume H0, the test the hypothesis that the die is unbiased. So I will assume that the die is unbiased. Okay, that is H0. Now then HN, null hypothesis. H0 H0 null hypothesis, HA means alternate hypothesis. So that is the die is biased. Okay, then or instead of writing die is biased, here the die is not unbiased would be better. So the die is unbiased and HA the die is not unbiased. Then second part, chi-square we need to calculate. So like in the previous question, we will assume that we have already assumed that the die is unbiased. So what should be the expected frequencies? So the expected frequency should be, that is, since the die is unbiased, we expect the frequency of each number is total here 132. Since it is unbiased, each frequency should be this total divided by, that means how many cases will come when you throw a die? You can get 6 points. Okay, either 1, 2, 3, 4, 5 or 6. So since it is unbiased, we expect the frequency of each number can be this 132 means total divided by possible outcome 6, that is equal to 22. So each phase can be, each number can be seen 22 times if the die is unbiased. Okay, so this is the expected frequency. Therefore, observed frequency 15, 20, 25, 15, 29, 28. Expected frequency, all it is 22, 22, 22, 22, 22 and 22. Then O minus E the whole square, that means 15 minus 22, that is 7. 7 square is 49. This is 2. 2 square is 4. 3 square 9. 49. 49. 36. So this is the expected frequencies. Okay, O minus E the whole square. Okay, now this is total, you will get it as 196. Therefore, O minus E the whole square divided by E. Here all the terms are going to be same only. O minus E the whole, O minus E the whole square, each term will be divided by the same number 22. So when you calculate that one more column and you will simplify, you will get the answer as, this is 8 point summation of O minus E the whole square by E, you will get it as 8.9. Okay. Then, therefore, this is what your chi-square. Now, third step, LOS. LOS is, I will take it as 5%. Then, critical value or chi-square alpha I have to find. So, for that one, degrees of freedom. Degrees of freedom will be total, how many are there? 1, 2, 3, 4, 5, 6. 6 minus 1, that is 5 degrees of freedom. So, corresponding chi-square alpha. Chi-square alpha at 5 degrees of freedom will be, again from the table, you will get at 5 degrees of freedom 0.05, it is 11.07. Okay, 11.07. Now decision. Decision is, since chi-square calculated value is less than chi-square table value, we accept H0. that is, or H0 was the die is unbiased, therefore the die is unbiased. Okay, so therefore whatever the fit was there, it is good. Okay. Now one more question of that type. Read the question well. That is, the question is, the number of car accidents in a city were found to be 20, 17, 12, 6, 7 and like that per month respectively. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 months accidents, number of accidents in a city is given here. Use chi-square to test whether these frequencies are in agreement with the belief that the occurrence of accidents was the same during the 10 months periods. Means we need to check whether, if we say, suppose you are saying the number of accidents in each month is same, we need to check that. Okay, so here it is given table value of chi-square is 16.9 at 9 degrees of freedom. Okay, so here null hypothesis I will take as H0, that is, the accidents occur equally on all months, and HA, accidents do not occur equally on all months. Okay, then second step, calculation of chi-square. So calculation of chi-square, again you write all this, that is, your observed frequency is given, that is 20, 17, 12, 6, 7, 15, 8, 5, 16, 14. Instead of doing like this, you can do it in a single, like chi-square is directly you are writing, that is 20 minus whatever E comes. Okay, in a line also you can write instead of doing this column. So I have written all these data here, that is all the given frequencies there, that frequencies are the observed frequencies. Therefore here if the accidents are occurring equally, total, this total is given as 120. Okay, so what should be the expected frequency? That means if we consider the accidents occur equally on each month, then in a month it should be, total is 120 divided by 10, then in a month 12 accidents must happen. Okay, so on the basis of the hypothesis, the number of accidents per month will be that total, this total divided by 10. So in a month minimum, in a month 12 accidents should happen if this null hypothesis is to be true. Okay, so 12 is the expected frequency for each month. Expected frequency is 12, everywhere it is 12. Okay, then O minus E the whole square you will find out, 20 minus 12, 17 minus 12, like that, and then O minus E the whole square divided by E. Okay, so when you calculate all that, you will get this answer as 20.33. So you need to calculate that. Okay, now so chi-square we got, therefore chi-square is equal to 20.33. Chi-square calculated, this is O minus E the whole square divided by E, sum of that one. So this is your chi-square. Okay, so now fourth one, level of significance, it is given, it is 5%. So level of significance alpha is 5%. Then and sorry, this is 2. Now critical value chi-square alpha is equal to, that also is given, 16.9 at 9 degrees of freedom, because total 10 and minus 1 means 10 minus 1, 10 minus 1 is 9, and chi-square alpha is given as 16.9 at degrees of freedom 9 and alpha 5%. Okay. So now fifth one, chi-square calculated value 20.33 is greater than chi-square alpha. That means we reject H0. Okay. Now we reject H0 means, that is your assumption was accidents occur equally on all months. We reject that one. Therefore, accidents do not occur equally on all months. Okay, so this chi-square test is a very highly applicable type of test which we can use in our daily life to check anything. Okay, so many things, means almost all the scientific study related to, say, medical field is based on, most of the scientific study is based on this type of statistical test. Okay.